Hello there. We are going to be doing permutations and combinations today in our lesson. And so, first of all, I need to tell you guys about factorials. And a factorial looks, the notation anyway looks like this, the n with an exclamation mark. And so you might be thinking that because exclamation marks usually require some excitement, you're going to be saying something like, oh, this is, 5 factorial. So it must be 5, but it's not, okay? 5 factorial basically means that it's 5 times 4 times 3 times 2 times 1. Okay, so this notation is kind of confusing, but it basically just means that you take the number n, like the 5, and then n minus 1 is basically, there's the bell, n minus 1 is 1 unit lower than 5, so the 4, and then you keep doing it. The dot, dot, dot is telling you that you're going to keep doing this pattern until you get to the 3, 2, 1 when you're done. So basically we go 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, and 120 times 1 is 120. So I just need you guys to understand how to work a factorial. Also, there is a way for you to get your factorial off of your calculator, and I'm going to get my calculator over here. And if you go with the calculator, it has a math option and then a probability option. And when you're in that probability menu, you will see option 4 for factorial, and you can calculate it on the calculator as well. But just need you guys to be familiar with factorials. Okay, so then after you understand factorials, we are going to talk about permutations. Obviously, this section is called permutations and combinations. So what is a permutation? A permutation is an arrangement of items in a particular order. You will notice that I underlined the word particular order. That basically means that the order of the items that you're arranging matters, which order it's in, which is different from combinations that we'll get to in a bit. So here's an example. In how many different orders or ways can 10 dogs line up to be groomed? So what I've done to kind of explain this process to you is I've written down the place in line. So this spot represents the first dog, second dog, third dog, fourth dog, all the way down to the 10th dog. Okay, so here's my options. Okay, so what I want to say is if you have 10 dogs, how many options do you have to choose for the first position? Well, there's 10 dogs. So you have 10 options. You can pick from 10 different dogs. Once you've picked the first position, the dog that's going to be in the first position, well, now you only have 9 dogs left to choose for the second position. So that's going to be 9. And then how many dogs do you have to choose from on the third position? You're going to have only 8 dogs left to choose for that position. And as you can see, what's going to end up happening, you have 10, 9, 8, 7, 6, 5, 4, 3, 2. So that by the time you're done, the last position is only going to have 1 dog left to choose from. So when you multiply all these numbers, is how you get basically the same thing as 10 factorial. So if I go to my calculator and type in 10, so I type the number 10 first, and then I go to math, probability, and then option 4, 10 factorial is actually 3,628,800 ways. That is how many ways there is to order these 10 dogs. All right, so now I want you to try an example on your own. In how many ways can you arrange 6 trophies on a shelf? Okay, so here's another example of how we can use permutations. In this case, it says 7 yachts enter a race. First, second, and third places will be given to the 3 fastest yachts. How many arrangements of first, second, and third places are possible with 7 yachts? So again, you can see here that we have our places. I have first place, second place, third place. How many options do I have for first place? Well, there are 7 yachts. So that means that I will have 7 choices for first place. But once somebody wins first place, then how many yachts are left for second place? 6, and then 5. So in this case, I don't care about the 4th, 5th, 6th, and 7th places. So I'm just going to go 7 times 6 times 5. And when I do that, I'm going to get 210, I believe. So there are 210 arrangements of first, second, and third place for this scenario. So we actually have another way of figuring that out. Here's our formula for permutations. It kind of looks funny, but you have a little n, a subscript if you will, in front of the p. P stands for permutation, and then the little r. And I've got here the formula n factorial, so it's important that you know what a factorial is. N minus r factorial. And then we have what n and r stand for. So n is the number of items total, so we had total 7 yachts. So in our case, for what we were doing, we have n equals 7 for 7 yachts. And r represents the number of items that are arranged at a time. So at a given time, because we only care about first, second, and third place, r is going to be 3. So if we plug this into our formula, that means that I'm going to get 7 factorial divided by 7 minus 3 factorial, which is the same thing as 7 factorial over 4 factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And what's going to happen here is that you're going to get 4 over 4, 3 over 3, 2 over 2, 1 over 1, and you'll have pretty much the exact same result that we had in the last example, where 7, 6, and 5 is going to equal 210. But again, you can already see that this is going to become very tedious when these numbers get very large. So I want to show you another way you can do this also on the calculator. And here are the steps in case you were unsure when I was talking about it earlier. You have math, probability, PRB. It's the last option in the math menu. And then you have options 2, 3, and 4 are the ones that we're going to concentrate on in this lesson. Permutations, combinations, and of course the factorial. All right, so how do we enter this in the calculator? Since n is 7, what I'm looking for is 7 permute 3. It is important that you first type in the 7, then you want to go through the sequence of math, probability, and option 2 for the P, and then you'll want to type in the 3. And when you do that, you in fact get 210. So we've done it a couple of ways where we can see how our answer is going to be. All right, so that is permutations in a nutshell. So I would like for you to try this one. How many arrangements of first, second, and third places are possible if you had 10 yachts instead of the 7? How would that change the situation? So you guys can work on that one. All right, and now we have this little guy. Need to move him out of the way here. Okay. And this guy is going to be kind of confusing, I think, but I want you to bear with me here while we go through this. It doesn't have to be confusing. But what we want to do here is talk about a combination, and how does a combination differ from a permutation. So in a combination, you have a selection in which the order does not matter. So earlier we had like the order mattered, first, second, third. So each option was decreasing by 1 every single time. But now we're talking about what if it doesn't matter. So it says, consider a situation in which the 3 fastest yachts win the race with equal status. Equal status, it doesn't matter if all 3 of them are going to win first place, so it doesn't matter which order they come in. So what I have done is to make this easier, and again we're going back to the previous example where we had 7 yachts. I'm going to go ahead and just give each yacht a name, A, B, C, D, E, F, G. So there's 7 yachts, 7 letters, okay? And we're going to fill this table with all of the possibilities for arranging these yachts in groups of 3, which is basically what a combination is. So what I've done here is I can take A with BC, A with CD, A with DE, A with EF, and A with FG. I can do the same thing with with the other letters. I can take B and go with CD, B and DE, B and EF, B and FG, and then I can get B and AG. Okay? So you can see that those are all different combinations. I can do the same thing with C. I can say C can go with DE, C can go with EF, C and FG, C and AG, and C and AB. All right? Then I can go D with EF, D with FG, D with GA, or AG, same thing, AB, and BC. And what you're going to see now is that I don't have to keep going. It's kind of getting redundant now. But what you can see is that you have these 7 letters here, 1, 2, 3, 4, 5, 6, 7. And you have these 5 options that are basically repeating. So 1, 2, 3, 4, 5. So in the end, we're actually going to end up with 35 possible arrangements. Now, I don't know about you, but this looks like it would be difficult to do if you kept increasing the number of yachts. So this is not the way that we want to do things for the future. I just kind of wanted to show you how it works. We know the answer is 35, so then what can we do to make this process a little bit easier for ourselves? Well, we have a formula for combinations as well. And again, combinations is where the order does not matter. So it's very similar to the NPR. There are a couple of differences. You have n factorial over r factorial times n minus r factorial. So there's the addition of this piece right here. That's what's different about this formula. But again, the number of items chosen is the same. So in this case, going back to what we were saying, we had 7 yachts, and I wanted to choose 3 of them, but it doesn't matter which order I choose them in. So that would be 7 choose 3, and we can plug that into our formula here. So that would be 7 factorial over 3 factorial times 7 minus 3 factorial, which is going to end up being 7 factorial over 3 factorial times 4 factorial. So here we go. We have 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we have 3 factorial, which is 3 times 2 times 1. And then we have 4 factorial, which is 4 times 3 times 2 times 1. Alrighty? And what's going to happen is that the 4 and the 4 will cancel, 3 and 3, 2 and 2, 1 and 1. And now you have 3 times 2 is 6. So it's going to cancel with that 6. And all you have left is 7 times 5 divided by 1, which is 35. Which is already the answer. We knew that from before. And then if you really want to get quicker, we can take the 7 choose 3. I'm going to write it over here because it's kind of in the way over there. 7 choose 3. And again, on your calculator, you want to type in the 7 first. Go back to your math probability. And this time choose option 3. And then type in the 3 from here. And you will get also 35. And this is probably going to be the method of choice, I would assume, for us to be doing this. Okay, so that is how we do combinations. So we have another example for you here of how we can use combinations. It says here, evaluate 12, choose 3. Again, like I said before, you want to enter the 12 first. Then you're going to go math to probability to option 3. And then you're going to type in the actual number 3, because it's a 3 here. And so when I do that, 12, math, probability, option 3, then I type in 3, I get 220. All right, so not complicated. You can try doing these guys here in much the same way. And then here we have an example of how we can use combinations in a more practical way or applicable way. A reading list for a course in world literature has 20 books on it. In how many ways can you choose 4 books to read? Again, it doesn't matter which order you read the books in, you just have these 20 books and you're trying to figure out how many different arrangements of 4 books at a time can I read. Alright? So again, we have N is the total number of items, and R is how many I'm going to choose at one time. I'm going to choose 4 at a time. So N is 20, R is 4. So I'm just going to plug into my little formula. So it's going to be 20, choose 4. And when I go to the calculator and do 20, choose 4, I get 4,845 possible combinations of 4 books that I can read at a time for this world literature course. So now you can attempt what would happen if you wanted to choose 7 books at a time or 12 books at a time instead of the 4 books at a time. So you can do that example. And then here's our last example of how you can get kind of crazy with combinations. It says 10 candidates are running for 3 seats in the student government. You may vote for as many as 3 candidates. In how many ways can you vote for 3 or fewer candidates? So first of all, 3 or fewer means that you can vote for 3 people, or you can vote for 2 people, or you can vote for 1 person, or you can vote for nobody. Okay? If you wanted to vote for nobody. Okay? So because you have 10 candidates, the option for how many ways can you vote for 3 people? Vote for 3. And how many ways can you vote for 3 people? Well, that's going to be 10 total people to choose from, and you're going to pick 3 of those. Then what if you want to do it for 2 people? That would be 10, choose 2. What if you wanted to vote for 1 person? How many ways could you vote for 1 person? That would be 10, choose 1, which is probably pretty obvious, but I want to show you how you'll still get the same answer. What if you want to choose for no people? That would be 10, choose 0. Okay? So when I go to my calculator and do 10, choose 3, I get 120. There are 120 ways for me to vote for 3 people. 10, choose 2 is 45. There are 45 ways for me to vote for 2 people. And then I have 10, choose 1. And this one should, the answer that you're going to get here should make sense when you see it. You don't even need a calculator for this. But if you're only going to choose 1 person, how many ways can you do that? There's 1 thing to choose from, so 10. What about this guy? There's only 1 way to choose for no one, and that's to choose nobody. But again, if you put 10, choose 0, you will get 1. So now, to answer the actual question, if it had asked for how many ways can you vote for 3 candidates, then the answer would have just been 120. But it didn't say that. It says, in how many ways can you vote for 3 or fewer? So now we have to add all of these numbers up together. So we're going to take 120 and 45 and 10 and 1 and get 176 total ways to vote for 3 or fewer people. Alrighty? So now what I need you guys to do is, what if you were actually going to vote for 5 or fewer people? How would that affect your problem? And once you've done that, then you have completed this lesson. Thank you for watching.